Welcome everyone. As said, today we would like to talk about Kubernetes-like control planes for declarative APIs. Um, and this is basically going to introduce the KCP project. I'm very happy to see people here and have them join and learn a bit about KCP before hopefully going into a well-deserved end of year vacation. So let's get started. Ma already introduced me, but just as a quick recap, I guess, yeah, I'm a team lead here at Kubermatic. My name is Marvin, and I am a maintainer for KCP. Our agenda today will be a couple of topics. We are going to start first with a little bit of an introduction, a bit of context. Why might this be interesting to you? Why is it interesting to me? Then we're going to talk about KCP itself, introduce some core concepts, especially those that KCP adds on top of Kubernetes. Then we're going to look at these concepts in a little demo, in a little practice. So I hope everything will work because live demos are always, dicey. And then we're going to talk about API management because that's kind of the core functionality that KCP brings in addition to the concepts it's already adding. And then we're going to look at that in a bit more, practical way as well. So you have seen how you do API management at KCP. And then we're going to go to the Q&A. So first of all, why I care about all of this? So platform engineering is maybe a term that you've heard in the last few years. I think I would say it's like maybe the last 3 to 4 years that it has been really gaining traction. Um, and yeah, as basically the slides are saying here, it's uh, a way for organizations to build what often is called internal platforms. Some people might have, how do I say this, flashbacks to the enterprise service bus. But basically, this attempt of building a kind of internal IT marketplace, a way for consumers within an organization to go to one like website or one like endpoint and get all the services that they need from that. And this is a recent thing, platform engineering. At least as a trend, the word has been around before. And honestly, the concept has also been around before because platform engineering is built a lot around APIs and offering, well, different kind of IT services via APIs. And this is not new at all. It's been, part of, well, it's been part of many success stories, and one where it's kind of part of the myth is AWS, because there was the API mandate by Jeff Bezos that basically said every team needs to communicate via APIs. And I would say that's the precursor of platform engineering in a way. Um, and basically the idea is that you can use APIs to provide services at a much different scale and in a much different quality than, well, if you like work your IT ops based on tickets. So that is basically the idea. And this idea has been, I would say, has been put into practice with the Kubernetes API. And more precisely, what I like about the Kubernetes API, and I hope some of you do as well, is the Kubernetes Resource Model. And that is the, well, central piece of how the Kubernetes API is built up. There's a nice quote here that is from the original description slash proposal of the Kubernetes resource model. So it's going back a few years now. But basically, Kubernetes is API centric. And it takes to this idea of APIs first. Well, it's an orchestrator. I can't send a ticket to an orchestrator. So the whole idea is it is API centric. And the Kubernetes resource model has a specific, well, extension mechanism. You have probably worked with that with custom resource definitions. And that has basically started a big success story when it comes to APIs in Kubernetes. Just a little technical, I just want to show this slide real quick. So the Kubernetes API is built up this way. So different resources, so different endpoints that you can send requests to. It's REST API at the end of the day. They're built this way. And you always know that they are built this way. And this is, well, um, with the extensibility of the Kubernetes API and this pattern, it's really easy to, interact with different API resources in Kubernetes. And the success story is basically what we can see on, for example, the CNCF landscape. Kubernetes has long, or the Kubernetes API in specific, has long passed this container orchestration, in the sense that there are many, many teams and many, many organizations that have built on top of it, that have built APIs that are served by the Kubernetes API, but that are not related to container orchestration. That's a huge, difference. Um, and I at least can think of an ecosystem in the recent past that has built up that much as cloud native, and that has also been built around these APIs, consistent models that we basically have in Kubernetes. And that is a really strong starting point. And it basically shows how powerful APIs can be, as a primary driver for IT operations, because operators, which is, the kind of marketing term for these kind of integrations into the Kubernetes API, they've been very, they've been there everywhere, I guess, these days. Like if you have a Kubernetes cluster, there's a good chance you're running an operator or like some other controller, something like cert manager, maybe. Um, Something like Crossplane, maybe, that there are many, many projects in the space that are kind of staples of IT operations these days if you're working with Kubernetes. And well, that's the nice thing. It's a declarative API. And so that means that for whatever service an operator is offering, I can say, okay, please, I don't need to know the steps to go to a specific um, endpoint. I basically want to know, I don't want to know how you will achieve this. I just declare, okay, I want a database, I want a certificate with this specific information and with this specific configuration. And declarative is in this way very powerful and very, I would say, and I hope that everyone agrees with that, user-friendly, because users need no longer to think about internals. They can just describe what they want. And that is a pretty easy step to take. So the problem with all the success is that Kubernetes wasn't meant as an API platform. It's a container orchestrator. And usually you don't run Kubernetes clusters across, let's say, data centers. Um, Even regions can be a bit dicey. A Kubernetes is, a container orchestrator first and foremost, an extensible one with a great API pattern, API design, but a container orchestrator first and foremost. To solve this problem, many organizations, many projects have basically tried to address this by running many Kubernetes clusters, because one big Kubernetes cluster usually creates a problem, or many problems actually, not just one. One of the solutions to make this efficient is what is usually called hosted control planes. For example, our product, the Kubermatic Kubernetes platform, KKP, is also based on this. The idea is basically the Kubernetes control plane. That is great. That's just a workload. It's not something where you need to deploy three distinct control plane nodes for each cluster, because that can, increase the cost quite fast, especially if we're talking about smaller clusters. Um, but instead, the control plane components can be run as a workload within a hosting Kubernetes cluster. And so basically each of these here, that's namespace in the Kubernetes cluster. It's not, I don't know, a couple like a set of three nodes or something. It's a namespace in each in which each Kubernetes cluster gets its control plane deployed. Um, so this makes things very efficient, because obviously you're getting rid of like three standalone VMs. Kubernetes is good, or is quite decent at resource um, stacking. And well, we get a lot of, high availability, scalability, all of that basically, because we're using Kubernetes to host Kubernetes. So this is kind of a turtles all the way down situation. And there's a reason that Cluster API, for example, has the turtle as a logo because of that. But this also, it's still costing you resources. Each control plane, it's a separate it's many different separate processes actually. And if you scale this, well, you will have increased costs. And depending on how you want to use Kubernetes control planes, this can still, end you up with, hefty resource bill or cloud bill. So now, how does KCP come into play? KCP comes into play because you might say, okay, I like Kubernetes, I like the Kubernetes API, and I especially like its extensibility. This is kind of the order interface that I want to establish within my organization. And that's something that has de facto, I would say, happened in a lot of organizations because, well, users do access the Kubernetes API to, for example, request a certificate. Like we saw all the different projects, and that was only like a cut from the CNCF landscape. The landscape is much bigger. But this is all Kubernetes API. This is not, or not necessarily the container orchestrator. So the container orchestration part of Kubernetes, you might not need that if you say, okay, I want the Kubernetes API and I want primarily the Kubernetes API. I want to extend it and I want people to order different IT services through it. You know, certificates, databases, whatever you can think of. So KCP basically took that idea and said, okay, what happens if you take the Kubernetes code base and you rip out the container orchestration part? Because that's the part that you don't need. And just focus on the Kubernetes API and the Kubernetes Resource Model. And that is KCP. KCP is basically trying to address the problem with having many clusters as kind of the unit of separation that you usually see because in Kubernetes, in a Kubernetes cluster, for example, registered APIs, they are registered through CRDs. And that means, well, they are cluster global resources. So two teams can say, okay, I want to register the same API or a similar API. That might cause problems, and clusters quickly get crowded, especially in the CRD space. And that's why you do hosted control planes, maybe, to give each part of your organization a smaller, a subset, like no, sorry, a smaller like cluster, and that they can use. And logical clusters in KCP are basically the next step, because in a hosted control plane environment, you still have your own data store for everything. You still have, many API servers running, many schedulers running, all of that for each part of your organization that needs their own Kubernetes cluster. Um, and KCP has a shared data store and is one, basically it's the KCP API server that is hosting like one set of endpoints. But depending on which part of the which URL you talk to, it will route you to different logical clusters. And each logical cluster will behave like a fully fledged Kubernetes cluster when it comes to the API parts. So again, no container orchestration here, but everything else, each logical cluster will behave like a separate Kubernetes cluster that you are talking to. So that means it has its own airbag, it has its own APIs, it has its own CIDs maybe, and each object obviously that you create in a logical cluster is not shared with other logical clusters because it's, kind of a higher level unit above namespaces. So what we use in KCP as a term is workspaces. They are basically a higher unit or above namespaces, and I will probably start talking about workspaces now. Logical clusters are mostly the underlying primitive. So this idea of, having multiple Kubernetes endpoints or Kubernetes-like API endpoints being hosted by the same server. And my door is ringing, and I hope that's not important. Um, all right. So workspaces. Workspaces are kind of, how logical clusters are exposed to users in KCP. So the idea is And I've talked about this mostly. Each workspace has its own available API resource types, API objects that you create, obviously not shared. Because workspaces give you this new like unit of isolation, you can delegate full administration of a workspace to its owners. So while in a Kubernetes cluster, you should be really careful about what kind of permissions you give users. So at the best, never hand out the cluster admin role. You can actually just hand out the cluster admin role on KCP because it will be confined to the workspace that it has been assigned in. And they people can self-organize, and that is highly useful um, to reduce the load on let's say the platform team that is running KCP. And because we have this logic here, the logical clusters basically they are just a different subspace in the data store. Um, there's no new API servers or anything that are being started. So workspaces are incredibly cheap because it just creates a new partition in your storage, and that is basically it. And that takes a few seconds. So new workspaces, they come online within like 4 or 5 seconds at best, or at worst. So yeah, that's workspaces. Workspaces also have this neat feature of being organized in a hierarchy. So this means this is extremely helpful to map organizational reality or organizational, org charts or anything like that into KCP. So when you create, you always have a root workspace, and under these you can create sub workspaces, and these are then child workspaces, and these can also have child workspaces. Um, so this is a very powerful way to organize and say, okay, some part of my organization it has like full permissions over this whole tree, but it doesn't have access here. Um, or you organize things more granular. You're fairly flexible in workspace organization because of that. And um, yeah, workspaces also have more features in KCP, are mostly centered around workspace types. So you can also impose some limitations. Okay, what kind of workspace can I create? What APIs will be available in the workspace? Who owns that workspace? There's a couple of features to basically make workspace management easier. And these URLs that you can see here, each of them is its own Kubernetes API endpoint. And that is what I was trying to say earlier. Each of them you can talk to with a Kubernetes client, and it will feel like a different Kubernetes cluster. Um, and that is kind of, how logical clusters slash workspaces work. Let's talk about KCP's history real quick. KCP has been started in 2020. There was, I think, a keynote appearance at KubeCon in 2021. At some point, the project became more community governance, community oriented, and eventually transitioned into the CNCF Sandbox. So it's a project hosted by the Cloud Native Computing Foundation, and at the moment, it's at the Sandbox stage. So, what do you build with KCP? So KCP, we as the project maintainers, we consider it more of a foundational technology. But there are like hopefully, or what we see is a huge possibility to build different things on KCP. So for example, if you have your own SaaS, why like develop your own API interface? Why not use something that is well understood, that has great tooling available, um, and allows users to order uh, like your cloud services via an API that they've been worked with before, and that is very structured, very standardized, and makes it basically easier to consume your services. Then there's obviously internal developer platforms, which honestly, to some degree, I would say are similar to SaaS, just with internal customers, like building the internal experience of developers or other stakeholders, allow them to consume internal IT services. Um, you can use it as a control plane for basically anything because the container orchestration part is removed. Maybe you know use it for orchestrating whatever needs you have. And now I just want to be a bit mindful of the time. I want to quickly show you KCP because this should have been practical, or this should be practical. So let's dive right in. So, all right. So let me make this a bit bigger. Let's move this out. And basically, what I would like to show you is that I went to the KCP website and so I basically started here, KCP as a website at KCP.io. We have documentation, obviously, in the setup, and we don't have to look at that because I'm going to show you. But basically, there's a bit of documentation on how to get started with KCP, and KCP has a very nice developer mode, which helps us just run it locally. We don't really need to spin up a Kubernetes cluster to deploy it into. We can do that. There's a Helm chart, but we don't have to. So what we're going to do is we're going to get started. I have downloaded a release of KCP, and I'm going to go run this now. So first of all, I need to unpack the archive that, well, KCP came in. And now all I need to do really is run KCP start. And that's really it. That starts KCP in this developer mode with an embedded data store. And it will now start and it will generate some information, some files. It will bootstrap itself. And this is going to take us a second or two. And after that, I have a running KCP instance that I can interact with. So let's start. Um, so KCP, when you start it like this, will generate a kube config for you. And that, makes it very easy to get started with connecting to it. So now I have my admin kube config here, and I have kubectl installed. So I can start with asking for workspace objects, actually, because workspaces are organized as Kubernetes objects. So you can see, oh, okay, I don't have any workspaces right now. I am currently in the root workspace, and there are no child workspaces. Now, to interact with KCP, we have developed a couple of kubectl plugins. So the kubectl plugins, they are documented on the website. So let me bring this up again. So I can install the KCP plugins from a custom crew index. So that is a plugin manager for kubectl. So we're going to start with that. So we're going to add the index, and then we're going to install 3 plugins that are very useful to interacting with KCP. So I can basically mention a little bit about that. So because we have this tree structure, it feels very similar to navigating a file system when you traverse the workspace structure, basically. So what we're going to start with is we're going to create a workspace. So I think the command works like this. So we're going to create one, and we're going to create another one here. And then maybe a third one. So now I actually see the workspaces. So now I have created child workspaces. And what you can see is what I showed you earlier is that there are now URLs that I can talk to and that get me the distinct like workspace that I want to talk to. So now we will navigate a little bit. So let's say I can go into my specific workspace because that's what I want to do. Then kubectl vs is kind of like cd, like the cd command. So what I can do is I can go in, and now I'm in a different workspace. I can also ask the plugin where I am. So this will tell me, okay, I'm currently in the Marvin test workspace, which is a child workspace of the root workspace. I can also do absolute paths. So this is also very similar to navigating a file system. So I can say, okay, but I don't really want to, now I don't want to like go into anything that's related to my workspace. I want to get out, basically start from scratch, start from root, and then go into the Kubernetes workspace maybe. And now I've basically switched there. And if I want to do um, well, like a relative path, I can also do that. So I can say, okay, I'm going to go up to root. And now I'm basically again in the workspace that I've been in. So now, right now, we won't see that much difference. But just as a brief check here, I can look at the API resources that are available in the workspace and keep this in mind because we're going to get back to this. So this is the basics of navigation. So you can see I'm using kubectl. I can just use kubectl to interact with KCP. I don't need a new client. Um, I just need a little bit of extension to kubectl to use it in the most easiest way. And just as a one quick check, let's take a look at the internals. So if I do this request to show me the APIs that are available, then we're going to see a lot of requests here, but I want to show you this here. So you will see here that this is a request to, this is basically the URL to my workspace. And then kubectl has appended this part here to, well, discover the APIs in a workspace. And basically this part here changes depending on which workspace you're currently connected to. And this is the main part of what the plugins do. They change the URL that kubectl will talk to. Okay, let's get back because we have, few things to talk about, and that is API management. So now you've seen you've seen KCP really briefly, seen me navigating through workspaces, but what do you do with KCP? Because it's nice to have, I don't know if it's nice to have, but it's interesting to have multiple Kubernetes API endpoints that I can talk to. But what is the purpose? Why would I do this? And as I said earlier, it's primarily API management that we want to talk about, that KCP is useful for. So this is what I showed you earlier. Basically, I can query all the APIs that are available in a workspace. I can also see that workspaces are actually just an API exposed via the same mechanism. Let's briefly talk about custom resource definitions. If you've worked with Kubernetes, there's a good chance you've worked with them before, you've seen them. But the CRD really does two things. The first thing that it does is the schema definition. So a CRD defines what schema the API resources are, the schema for the API resources. How will the resource look like? What kind of objects can I upload to the API? But creating a CRD does a second thing. It registers the API immediately. So it gives the schema definition, but it also does the registration. And these things are two distinct things, or they could be two distinct things at least. Let's go back to the workspace tree. So if I look at this, um, if I look at the workspace tree, there's always going to be different parts of the organization that, offer something that other parts of the organization would need to use. So think about it in terms of, maybe there's a database team, and the database team wants to start offering a managed database service within an organization. Um, then the managed database team would be team A in this example, and if we go by using APIs to provide the service and not by emails or tickets or whatever as a primary way, um, then this team here, it would provide the API schema. It would define, what kind of API am I offering? How should the database schema, like how should the database object look like? Database schema is something different. And it's also responsible for taking the objects that people will create and reconcile them. So create a database actually, keep the database up and running. All of these kind of things that, in an IT organization, you will always see there's always providers and consumers within an organization. And in this example, we would have two consumers. So How does this work? Because CIDs are cluster scoped. So if you have been following me so far, that means that if team A created a CID, because a workspace is a logical cluster, the CID would only be available within this workspace, within the team A workspace. But it wants to provide its services to other parts of the organization, so that doesn't work. So KCP introduces a concept that builds on top of CIDs and takes these two things that I talked about, the definition of the schema and the registration, and pulls them apart. The API export object is the first part. The API export is the definition of a schema, or actually in this case, it's bundling a bunch of schemas. And this is what Team A, what the database provider would create. This is basically them saying, hey, I have an API to offer, and I am exporting that API. But an API export itself would not make the API available in a workspace. Like I couldn't create database objects from an API export, even though the API export defined a schema for database objects. This is an example of that. We're going to take a look at that in a little bit, in a also more practical way. But basically, resource schemas, they look like CIDs. We're gonna see one later on. Now the other part. The other part is API bindings, and API bindings is this registration of an API. So it basically, like it binds or it activates or whatever you want to call it. It takes an API that is defined in API export and makes it available in a workspace. And the important bit is that it doesn't have to be in the same workspace as the API export. So this is basically one of the ways for um, to deliberately break down the barriers across workspaces. This is all guarded by airbag, so you can't bind an API that you don't have permissions to bind to. But in general, this is one of the things where, we don't want full cluster isolation. What you would have if you ran different Kubernetes clusters. And try to connect them and all of that, would need to have more logic basically. So this is how it would look like. So there's different teams and they create API bindings, and these API bindings refer to API exports. And that means that now if we have team A as our database team, team B and team C, they would bind the API, and in their workspaces, they would they would have the database object available, the database resource available, and they could create database objects now. And team A is the one responsible for taking all these objects and reconcile them. So how would that work? Because the database object that would be in this workspace. Team A wouldn't have access to that. Now we're getting into the nitty-gritty details of providing services in KCP, but this is also part of, something that you just should know when you get into KCP. So let's briefly talk about it. The core concept here is virtual workspaces. So virtual workspaces, they are basically another set of Kubernetes API endpoints, but they don't have their own storage layer at all. They basically proxy the data that is living in KCP and transforms them. So basically, in this specific case, so virtual workspaces, you can basically write whatever virtual workspace you want to have. There's an SDK that KCP uses to build its own virtual workspaces, but you can also build ones that do other kinds of filtering on the data that is in KCP. But in this specific case, if I have created an API export and I want to provide that, want to reconcile that API, because providing an API in itself won't do anything. In this specific case, there's the API virtual workspace. And this will basically allow me to read all the objects that have been created from my API exports in other workspaces. So this is basically the logic. So this is another like deliberate breakdown of isolation, also guarded by airbag, to have access to the data that you are supposed to have access to. And these kind of advanced, filtering logics, they don't exist in Kubernetes. Um, so basically, to reconcile my API, I write a controller that is KCP aware and that talks to a virtual workspace to reconcile, in this example, my pizza and my certificate objects and does something with them. So this is basically how this works and how Team A, in our example, can provide their services to many different parts of the organization without, having access to the full data set that, the other parts of the organization have. Okay, now let's get into the second demo because I want to show you this in a little bit more. Okay, what are the YAML files involved here? What's going on? So let me bring up my terminal again. Let me move this out of the way. So now we so we still have our KCP running here and I'm still connected to it. So what I want to show you is I want to show you the files that you would typically create to provide an API. So we have a phase one. So first of all, we're going to create a special workspace. So this is an example that the maintainers built for KCP. We're going to just walk through it step by step. So the first thing that we want to do is we want to create a new workspace because let's say my team is a widgets team. It provides something. It provides a widget service. Then usually that would mean that the widgets team has their own workspace. So we're going to start with that. We're going to create widgets. And I don't have the alias here, so I need to do it like this. Okay, now we can see another workspace has been created and we can change to that. So we can go and get into the widgets workspace. Now, we need to create two resources here that will help me provide an API. One of them is the API resource schema. And this, if you have worked with cities before, you might recognize this. This is basically a CRD definition. It's its own API, like it's its own resource type, but fundamentally it takes it's trivial to convert a custom resource definition that you might already have to an API resource schema. So this is a API resource schema, so a definition of a schema for my widget resource type. So this is what I will create. Okay, now I have created this definition, but I also need to advertise to others, hey, you can use this like bundle of resource schemas, and that is my service. So for that, there's the API export. And the API export that I have here is fairly simple. One thing that it does is it references the resource schema that I've just created by name. And it also uses an advanced feature that is called permission claims. So permission claims are a way to extend the virtual workspace that we have seen before with more information. And users of my API, they will need to accept the permission claim to basically say, okay, yes, this service provider, it should also have access to secrets in my workspace or to config maps or to namespaces. And this might be necessary if your API, for example, has a secret reference embedded or something. But this depends on what you're doing with your API. So we will also create an API export. So now as a service provider, we're kind of done. We have created an API resource, we've created an API export, and now we want to start binding this. So let's go to the next phase. So we're gonna go back to the root workspace because now we're on the consumer side. So first of all, we're gonna create a workspace type. I have alluded to this briefly, but basically you can define a kind of template for how workspaces will be created if you, well, instantiate them. And in this specific part, we are going to have a bunch of default API bindings, in this case only one, that binds to my widget type. So we're going to create that. All right, now we have a new type. KCP knows how workspaces should look like of that type. And then we're going to create two new workspaces because these are now the other parts of my organization that want to be consumers of the widgets service. And as you can see here, they reference the workspace type that we've just created. So we're going to do that. We're going to create a workspace. We're going to create two workspaces actually. And you can see them here. Uh, muscle memory. Um, now we're basically, things are starting to get a little crowded, but our two consumer workspaces have been created. Now, let's take a quick look. If I look at API resources in my root workspace, you will see something, namely that there are no widgets here. We don't offer widget API in this workspace. Okay, cool. That makes sense. And now I'm going to go to the consumer one workspace because here, if I now look at the full list of APIs offered here, we will see that there is actually a widget API here. And this is the thing basically that I wanted to show, that the APIs in different workspaces, they are actually different. They are different, or there can be different APIs registered. So that is basically, we've set up the consumers. Now we need to do one thing, because obviously something that also needs to happen is the reconcile. So someone needs to take the widgets and do something with that. So we're gonna do that. And yes. So we will also use the KCP admin kubeconfig here. And for that, we're going to start an example controller that the maintainers that we have written based on a controller runtime version that KCP is offering to run, well, yeah, to run KCP-aware controllers. So there is now a KCP controller here. Let me quickly check if we're in the right workspace. I think we need to start from root. So we're going to start the controller here. And the controller now has connected to the virtual workspace. And now if I create widgets, so if I'm basically the user, there's a little widget here. It doesn't do really anything. It's just, a very simple API object. But basically, I can create now a couple of widgets. So what the widget controller does is it counts the amount of widgets at the time of widget creation and writes that information back to the widget. So, pretty simple, just some dummy code. But that means I can create multiple widgets. Ah, yes. See, I need to be in the right workspace because it doesn't work without being in the right workspace. So now we have a widget, now we have another widget, now we have another widget. So now you will see that we have three widgets. If I look at one of these widgets, I will also see that it has a status field. And this is basically all the controller does. Again, just a dummy controller, but it has counted the amount of widgets in this workspace and written that information back to the widget. And just before we close, I also want to show you what this looks like in the other workspace, because there are two consumers of this API. And now you will see that I don't have any widgets here. There are no widgets. And I will create another one. And now what you will see is that if I look at the list, okay, there's one, that is great. And if I look at its status field, you will also see that it only counted one. because, and this makes sense, it's counting within the workspace. So the controller is reconciling widgets across multiple workspaces, across all workspaces using this API, but it is workspace aware. So it basically can separate these things and do operations based on that. So with that, let's jump back into the slides. And just as a brief, why Kubermatic cares about this, why I care about this, is apart from it being cool technology, is that Kubermatic builds one of the, I showed you that we think there are many things that you can build on this. And this is why we think KCP is a great community project because it's foundational technology. And we at Kubermatic, we are building the Kubernetes developer platform, which is something that we've recently announced. And this is basically an internal developer platform that's driven by the Kubernetes-like APIs that KCP offers. With that, I got a little bit over time, but I'm not doing too bad. So with that, thank you very much for listening so far. And if there are any questions, now we can basically discuss them. And I might need help from Mar because I'm not sure I can see the chat here.
Yeah, you should see on the bottom the Q&A. Now we have 2 questions. I'm not sure if you see it. If not, I can.
Yeah, maybe you can just read them to me. I'm not using Zoom that often.
Okay. So you have one which says, I would run my custom controllers against the virtual workspace, which was created by my API expert to reconcile all the instances of my CRD there. Is that correct?
Yes, exactly. That is exactly what this controller would be doing. It runs, I can jump through the slides, but it would basically run against this endpoint here, and it would see all the different objects and it would reconcile them. But yes, that is exactly it.
Then we also have another question, which says, is KCP an alternative to crossplane, or would it might be sense to combine both?
So it's definitely not a replacement of crossplane. It's kind of more low level because it's just the ability to offer these APIs. So what we think is that combining this with crossplane might be a good idea. So basically, crossplane offers you wide like a extensible way of offering cloud APIs or like other kinds of objects. And with crossplane or with KCP, like a crossplane KCP integration could basically give you better separation of these objects. And this is, I think, where hopefully in the future these kind of projects or these projects can, more cooperate.
Thanks. There's more. I will go to the next one. Can we create a pod deployments in Workspaces?
So these APIs have been removed. I can briefly show you. So if we go here and we look at the available APIs, something that you won't see in here is pods or nodes or deployments. You can reinstall these APIs as basically via an API export. That has been something that earlier versions of KCP supported, and it was called transparent multi-cluster, where basically you created a deployment and the deployment was spread across multiple Kubernetes clusters in the background. This is no longer actively developed in KCP because we focused on the API part, but you could definitely like build something like that. Or if you're interested in contributing, even better, maybe the TMC component, which is kind of an add-on, I guess, for KCP, maybe we could revive that, and then you would be able to create pods or no pods or deployments. But you wouldn't be able to do this with stock KCP now.
Thank you. Next one is, how does KCP differ from vCluster, especially with respect to multi-tenancy?
So my understanding of vCluster is that it runs a stripped down version of the Kube API server and then syncs from that to, a bigger Kubernetes cluster. So and I have to jump quite a bit through the presentation to go back to the beginning. Um, I guess, and I'm not the most um, I'm not a vCluster expert, but my understanding would be that it's kind of like a mix of hosted control planes and having like a shared big Kubernetes cluster that the smaller vCluster control planes that they orchestrate basically. Um, but that still means you have like a different, you have separate vCluster instances. They are still different pods, and all of that. And in KCP, you only have logical clusters. So you have one KCP process that you can scale it horizontally, but it's one KCP that you're talking to that basically does all of this. So in vCluster, you have multiple lightweight API servers that aggregate all the information into a bigger one. And in KCP, you only have these, logical API servers that, cost you basically no memory or CPU. That makes sense.
Thanks. Um, the next one is what is the process of clean decommissioning of services or APIs, whatever I can do with KCP, if there might be a dependency between on various resources?
That's a pretty good question. Um, hmm. So in general, you can describe dependencies between APIs with something that is called an identity hash. So that uniquely identifies the API that you have that you're offering. Um, and this basically allows you to have access to different APIs, to different API objects that come from a different API export, maybe. Decommissioning is an interesting question, though. You can't, as long as someone uses your API, as far as I know, you can't delete it. So you would basically need to, well, I guess, hopefully not send an email, but basically make it clear that your API is deprecated, and basically, work on migrating everyone off that API. Since that's not necessarily really a technical thing, but more of an organizational thing, KCP only addresses it in a limited capacity. But it would be maybe interesting to think about features there.
So far there are no more questions in the Q&A. Not sure if anyone else is typing or wants to ask something else. Let's wait 1 minute. But thanks a lot, Marvin, for your presentation and for all your answers as well.
Yeah, if there's a follow-up to any of the answers, also feel free to ask. I hope I could
Yeah,
answer them though.
exactly. Yeah, and if further questions come up in a later moment, you can also always reach out to us, and we are always happy to help.
Yep. All right.
Yeah.
Then I think it's my time to say thank you for listening.